first is come here. The data set is this. So I will come under download, then I copy this. Okay, upon copying this, it tells me import cable hub. So this will provide me with a path of interest. So I bring it there, and that's what I have. So first thing I do is to run that. Once I've run it, it will specify, because I asked it to print the path to dataset files. So it has printed that path to dataset files is that which we are seeing. So the second step, I'll go to my notebook, as I have had it. So I need to import the necessary libraries that will enable me bring this data set where I want it.
For instance,
so first thing I'll do is to bring this here. So the first library I'm talking about is import pandas as PD, then also import OS. Now these ones, these libraries will assist me. The first one, import Kaggle Hub, assists me to access the download from the Kaggle website. But this other one now assists me in uploading this into my notebook. So pandas does that, where we import pandas as PD, and we also import OS. Now upon running this again, then we'll see that the particular name of the dataset is finance economics dataset. It's a .csv. It's a .csv file. So once I've specified that, the next thing that I needed to do now is to bring this other code. Realize that these ones are prepared beforehand because I didn't want to take much time typing them. So upon bringing this here, that's what I have. If I run it, then it gives me all this. So what it has done is that it has accessed the data from the website directly. And it is real and live data, as we can see. But then what we see here is that we have columns. So probably before we get here, I can now let me first do a little inspection by saying df.info. So that will help me identify the columns that are in this data set. So here we see that there are 300 entries. That is from 0 to 2999, and there are 24 columns. Now these columns, the first column is date. We have stock index, open price, close price, daily high, daily low, trading volume, GDP growth percentage, inflation rate percentage, unemployment rate, interest rate percentage, consumer confidence index, government debt in billions USD, corporate profits in billions USD, forex USD stroke euro, forex USD stroke Japanese yen, crude oil prices in USD per barrel, gold prices in USD per ounce, real estate index, retail sales, that is billions in USD, bankruptcy rate percentage, then mergers and acquisition deals, venture capital funding, consumer spending in USD, billions USD. Now you can see that this is such a rich data set, and it can assist in understanding much of what we are interested in doing. So this one gives me, and I asked it here to print DF head. DF head simply means by default it gives us the first 5 entries in the data set. So we see that the first column is the date, and here we see it. Then stock index, we see we have Dow Jones, S&P 500, Dow Jones, TPC. They keep oscillating as such. Then the values there for various columns that we refer to. So that's basically what the F head does, and that's what it is. So the DF info here was just meant to help me identify the columns as they are, and I see that this is what they are. Now we can see that date is an object because probably it contains also non-numeric. It contains there are dash, there are some hyphens in it. Then open price, you see it is indicated float when we expect it to be an integer, meaning that they may be having the elements of commas, so and so on and so forth. So what we do next, having done that, is I want to pick the next thing. The next step probably is that of having to clean. That is to there are certain columns here that are likely to be having outliers. and such columns as identified will be close price column, GDP, growth percentage, and inflation rate percentage. And I'll be using, I'll be removing outliers by setting the first quartile at 0. The first quartile I'll set at 0.25. That's the first quartile, and the third quartile, which is the upper quartile, at 0.75. So this is going to ensure that I take care of values which may be extreme on the upper tail and the lower tail. So upon picking it as such, I bring it here.
I'll use this,
and that's what it gives me. So once I run, it tells me that after selective outlier removal, we have 3,000 rows and 24 columns. So basically, the data was clean, and there are no rows that have been eliminated, and that's why we have that. So the next step, I didn't intend this video to be so long. The next step is now to pick the code that should give us the main topic of this analysis. So I'll collect it, and probably after collecting it, that's when I'll describe it briefly.
Then we'll have to note. So already we know this.
So let's see.
This is 4.
What it is here is that first thing what we need to do, it is market daily dynamics analysis. So all these are libraries that we have imported to assist us. There's NumPy to help us with handling the figures. There's Plotly.graph, that is for visualization, and also PyPlot from MATLAB for visualization. So the first part here, we load and prepare the data, and that's what it is. So load and prepare the data, that's what it does. This one will now convert date column to date time.
So the next thing I need to remember.
Then the third one here will compute daily returns and volatility. And this one will help us get the plot. And as such, so the fifth one here, the fourth one should give us the plot daily returns and rolling volatility, and then this should give us the summary statistics. So let me run it and see what we have, and then we see what we can make out of it. So probably that's what we have, and as you can see, then we already have an output. This output here is that of daily market price movements, and it is plotted as such. So this one is for visualization purposes, and bear in mind that we are dealing with global data, and it's global data that runs all the way from 2000 to present. So what we have here is the market returns and volatility over time, and what it shows us is that it illustrates, probably it illustrates the behavior of daily market returns in blue and 20-day rolling volatility in orange. So both are expressed as percentages derived from the finance and economics datasets covering 2000 to 2008. Now, this dual line visualization offers a concise look at how short-term price changes translate into medium-term risk accumulation. So first, daily returns fluctuate sharply with periodic spikes exceeding 200%, as you can see, exceeding 200%. This represents market reaction episodes, likely responses to macroeconomic news, policy shifts, or global market turbulence. Then we can also see that there is also volatility clustering. The orange line representing the 20-day rolling volatility demonstrates the phenomenon of volatility clustering, periods of high variability followed by calm phases. This confirms a key feature of financial markets, that is, risks tend to persist once triggered. Risks tend to persist once we are able to implement. So the third one, the third aspect we want to look at here is that the cyclical or the cyclical risk patterns. Now there are noticeable peaks. Noticeable peaks appear around 2001. Okay. 2001 to 2002.
before I perform this particular
and 2006
there's a library
to
that I need
2008.
because this
Aligning
now
with
a
major
different
historical events
environment.
such as the
There
dot-com
is
correction
a
and
library
the
that I
global
need, and
financial
this library
crisis
is
buildup.
import
Now,
math.
we
Because
can
I'll be
also
using
have
various,
another
math
dimension of risk
operations.
return
I
trade-off.
need that.
Now, when
So
volatility
having imported
rises,
that,
daily
my next
returns
step,
often exhibit
now I
wider
prefer
swings,
to go to
underscoring the
another
risk
cell.
reward trade-off
Yeah,
fundamental
so
to
that I leave
market
that specifically for the
dynamics.
library.
So,
in this case, let me run it
this
anyhow.
particular
And now
diagram
next,
here, this particular image
I want to
tells us
specify,
much
because in
about
my
the
question,
global
there are certain
market returns and its volatility
there are
over time.
certain,
And if you take
there is
time
some
to
information that
go
I'm
through
given.
it and
For instance, I'm given that
think through
PX is equal to PX
my
given
verbal
is equal to
communication
6.
or my lecture, then you'll realize that you can
I'll say
have
6.0.
it or put it in sync
I'm
with
also
the
given
diagram that you see here.
QX,
So probably
QX
another thing that I need to
is
add,
equal to
we can now, if
4.8,
that's what we have, that's the situation, that's what the data
8.
reveals, then
I'm
we should
also
then
given that
understand some of the
XS
analytical implications of the
XS
data. So first,
equal to
portfolio management.
5.0.
Investors can
I'm
use
also
rolling
given
volatility metrics to adjust
RT,
exposure dynamically,
RT
increasing
as
holdings
8.
during calm
RT
periods and
given
reducing them when
as
volatility
8.
spikes.
So we have 8.
Another way,
and
another implication can be
0.
seen in terms of
So
risk forecasting,
those are
combining
some of the
short
dimensions that I've
term
given.
return
As
shocks
you
with
could,
rolling volatility
as you
enables
could,
the
clearly
calibration
see from
of
this
value at
particular,
risk, that is
question.
VAR,
The
and
dimensions are
expected
given as such.
shortfall
So those are the
models.
specific dimensions
Now,
that
if you want to
I'm
access
dealing with. And you
the
should remember
full
that we had worked
report
out
of this
QT,
particular analysis,
QB12,
then
set
you should
return. So you want to
visit
confirm
our
if by
website, that
using
is
a Python script, we are able to get
datalyticsacademy.com,
the value
and then you
of
get to the blog section.
QT.
You'll
So the
find
dimensions that
all
I've
the analysis
specified,
that I've ever done,
within the,
plus their reports posted
within
there.
the
So
Python environment,
another way
then
that we can look at the
environment
implications
are
of
just these entries here. So I'll proceed.
analytical implications
So having
of this
done
particular
that,
result is machine
then
learning
I
integration. This
need
visualization
to
can
find
serve as
a
a
way of
baseline for
incorporating
feature engineering in predictive
the
models such
intersecting
as the
chords
GARCH,
theorem.
the LSTM,
And
or random forest regressors, linking
to
volatility
incorporate the
persistence
intersecting
to
chord
future
theorem,
market
I'll need
outcomes.
to remember
Now,
my
today,
expression,
as I said,
the
I didn't want to
expression that
take
I
much
had.
of your time,
There is an
but
expression
I
that
felt
I
it
had here.
necessary to talk about
There is an
this
expression that I had.
particular aspect of the
Well, I
analysis.
deleted
As you
it,
have seen, the data is
which
huge.
had
There is
expressed
much analysis that can be done. There is much that I've already done. That's why I'm directing you to the website, the blog section, so that you can have a feeling of what data means. Because I mine the data as such and use my knowledge to analyze it and avail it for your consumption. So you can visit my website,
so in
and then
brackets
check
I'll be having
the reports that have been there.
XS times
Have been there for this time.
XS times.
So down here, then we see summary of daily returns,
times.
and we see the count is this, and then the mean is 20.85. Standard deviation is 78. Now that's B. If the mean is 20 and standard deviation is 78, I think that indicates
and all this
uncertainty, wide uncertainty. Now we are talking about a mean. That's
an expression we had where we were arriving with the value, where we arrived at the value 4 centimeter.
That is the minimum.
The divisor was
negative 79.
And that's
the upper quartile, no, the lower quartile is about negative 34.
So that we
the middle quartile, which is the median,
we don't
is now 0.32, and then the upper quartile is 53.21.
This represents
now, maximum being about 390.664. Now,
internally, let me just say,
I'll take time to look at to consider other analysis so that we make out the meaning. We make meaning out of this particular summary. So for now, I want to stop at that, and I hope that you follow us to our website so that you get much insights of what the data that is publicly available reveal about the patterns
to define whole code
data sets.
Because
now this will be important in helping or shaping policy making direction. I want to stop there, and I'll be coming back with another set of analysis in a moment. So I stop there.
Given by
I'll see you
px
in my next video.
Px plus xr, because I'm finding xr here. Px I already have here, but xr I'm finding here. So upon finding xr, I'll be having that output as the input in the expression for PR. Then next thing that I'll do is to define a whole second. A whole second is from T to P. Remember, I've defined PR to be XR, PX. I've defined PR, that is P to R, to be given by PX plus XR. That's what we have just done. But now I'm saying I can also define TP to be equal to RT plus PR, and realize that PR is 10. So I come here and make another definition that TP is equal to RT plus PR. RT plus PR. Now that takes care of that. Then on to for me to find QT, I need to specify another theorem. And for that reason, I'll just run this code as it is. I'll just run that cell as it is, so that that is already taken into the memory. But I want to move to the other cell because I want to talk about another theorem. And this theorem, we refer to it as tangent. We refer to it as tangent second theorem. Tangent second theorem. And we can, the right way to put it would be to say QT, no, it's QT as such, and we say QT, I'll just say QT times QT, of course it's squared. Let me have this so that it looks neat. QT times QT as such is equal to, or the other way that looks better is QT raised to power 2 raised to power 2 is equal to RT times TP. It's RT times TP. So this should imply that QT is basically the square root of RT times TP. So I'll end by saying that QT, I give the expression that QT is given by, now I call math, and so I'll say dot square root S QRT, and I want square root of the product of RT by TP, whatever is up here. So if I input it here, then it gives me that. And probably, let me see, if I run the cell, oh, I'm told there is a problem somewhere, and it's got something to do with, because I'm told it cannot assign to expression here. Maybe you meant instead of that. Now, why is that? It could be with this. But another way I can write this is, I can go about that by also saying again QT. Let me see if that passes the test. So what's up here? QT, 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 QT. QT, QT. So we are saying that QT squared is equal to RT, that is QT squared let me see, it should be, we have this, and I also have that, then I bring this to be squared. Will that pass the test? No, not yet. So probably the next thing that I need to do is on the second theorem, tangent second theorem, we have that QT squared. So this implies that QT, it then implies that QT is equal to square root of this. But then I'm having QT. So let me see. Let's see what is here. Now, there seems to be an issue with that particular code. Let me see what I have. Let me see what I have. Oh, it should just be this. Yeah. So if I bring it here, then probably what I need is just this. Yeah. So that if I run it, I get that. So that sorts it out. And the next thing that I need to do probably then is to print all the dimensions as required. And so probably not to waste much time, I'll collect this as such and then bring it here and then bring them here. So this code is simply saying that we give these values to two significant figures. We give XR to two significant figures, PR to two significant figures, TP to two significant figures, and also QT is also expected in two significant figures. But we are now going to print the value that we get. So upon clicking, we get that XR is 4 centimeter, PR is 10 centimeters, TP is 18 centimeter, length of QT is 12.0 centimeter. So that wraps it up. And if at all we had needed to do some sort of visualization as we change the lengths, then that we may consider in another meeting. For now, I pen off and I say thank you.